Today, our topic is the bootloader. So, main topic is gonna be bootloader. But first, to understand what's the bootloader, you have to understand the how we came from the bootloader. Actually, when you're trying to make an operating system, you will able to see some blog or YouTube that talk about bootloader, and not you might confuse that why we need such a bootloader. I thought we just gonna make an operating system, right? But the thing is that yes, we really have to make about bootloader. And then what is a bootloader? So bootloader is the first software after the BIOS, and that boosts the computer and that finds the operating system kernel image and that sends to the RAM and make it execute. Yes, this is very simplified of explanation about bootloader. So let me try to give example for you. When we try to use our laptop or computer, right? There should be power button, and once we click the power button, and our computer boots it, and we are able to see some kind of our profile and the password, and our keyboard is of course is working, and we will type this input field, and this sounds really simple, right? And we just turn on the first step. We just open the laptop, turn on the button, and wait for the boots. Wait for our Windows or Mac OS is working. And once there's input field, we type our password, and everything's gonna be work, right? But these are really simplified version of it. We are computer scientists, and we really have to know about what is happening under the hood to work to see how it works. So first is the BIOS, and second is the bootloader, and third is kernel, not operating system kernel, OS kernel. So, what's the BIOS? BIOS stands for the basic input output system. What it does is it checks your core hardware, like example CPU and RAM, ROM, hard disk, those kind of key hardware thing that makes your operating system work. But why? Why we need to check our hardware stuff to see how our operating system works? It is because your operating system is directly related to the hardware. Operating system is just a memory management tool, which kind of years of memory management. It handles our application runs, and it handles how our application work in synchronously, and it just so relate to the operating system. Yes, and so operating system is the software that does everything for you about memory management and those kind of stuff. So that is why we have to check our hardware, this is working or not. And what it does is, of course, it checks your hardware, it is working, but we call it doing post. Post. Actually, this is not the same concept or same meaning of the post in RESTful API. In the RESTful API, the post means we send our resource, and we send our resource to the server, right? And we store our resource to this. There's some backend stuff, right? But in this concept, in the BIOS world, then this post meaning is the power on self test. Power on self test. Sorry, it's just self testing is power on is working or not. And then for that is the bootloader. Yes, we have to make a bootloader to make this kernel work. And as I said, the bootloader is the one who boots your computer and it checks the kernel image. Check, I think find is more appropriate. Finds the kernel image and it sends to the RAM and make it execute, and that is how it works. But I will simplify this, the bootloader code, the bootloader concept. So let me elaborate for you more. The first thing, we have to separate this part, right? So bootloader is the code directly handles or communicate with our hardware. Why? Because normally we rely on the operating system to communicate with the hardware, right? But the thing is that the bootloader doesn't rely on the OS kernel or operating system because the bootloader is the software that executes before even OS kernel start. So bootloader is the code that directly communicate with your hardware. And let me elaborate more. So what kind of hardware? We store this bootloader to our hard disk. And the reason why we don't store bootloader in the RAM, because in the RAM is when we turn off the power, everything that stored in the RAM is gonna be gone. That is how we treat this RAM as a memory. So it's called the volatile memory, but the hard disk those kind of stuff and it's called non-volatile memory. And yeah, we should not erase this code because we should store in some kind of safe place and safe place that even did not erase despite of power off, right? So we have to put this bootloader code in the hard disk. Hard disk. So what is hard disk? Hard is type part of non-volatile memory, and it just looks like this. I'm just gonna try to drawing for you. There's a really round thing, and this is called platter. And there's example I'm gonna draw three, and these are the arm, and this the head of it. And when you closely look at the how platter looks like at the top, and inside of this round outline, there is a multiple tracks of it. So these are called tracks, and this really one part of it is called sector. So imagine just like a record pen. So when 1940s and 1960s or whatever, we used to play our music using record pen, right? Those round stuff, and when we power on it, the needle is gonna be stick with the round record pen and let it runs, and this round record pen we're gonna rotate and there's gonna music playing, right? So that is similar part with the hard disk. It rotates and it finds the track of it and you find the specific sector of it. So let's go back again. Where do we store our bootloader? Well, we store our bootloader in the first sector of the hard disk. So that's kind of promise in this computer science world, and what I mean promise is kind of interface or protocol that is this had to be definite. So, but why we need such a promise or protocol? It's because there should be some kind of promise-based interface, because we are writing code, and if there's if there's like mm, interface that we don't match, there's gonna be some kind of error happening, right? So that is why we made such a promise, and inside this comparison and especially the bootloader stuff. Sorry. Yeah. I'm sorry. I'm just gonna part off this first. So inside the bootloader, and there's a promise that we store our bootloader code into first sector of the hard disk, and this first sector is also called as the MBR. MBR is also called the master bootloader record. Master MBR. MBR stands for the master boot record. So this MBR sounds really hard, right? Sounds really difficult. So I recommend you don't memorize this, just understand it. Okay, if there's a first sector, we store our bootloader code in the first sector of it, and it's called the MBR. Simple, right? And the more thing I have to talk about is the size of the bootloader code has to be less than 500 terabyte. Why 500 terabyte? Why? Why our bootloader code has to be less than 500 terabyte? It's because the sector size of the hard disk is 500 terabyte. That is why we store our bootloader code less than 500 terabyte and reach the first sector of it. So that's kind of related because bootloader is the code that directly stored in the hard disk hardware. And also we can store in the hard this part, right? And 500 terabyte is the maximum size, and actually there's more of it. Inside 500 terabyte, 64 byte, I think it was 64 byte. 64 byte is validation, and the other byte except 64 byte is the main function, main logic. So this is it. And this is how it works. So, but if you're trying to write a bootloader, you might really confuse that because to print the hello world requires understanding of BIOS interrupt, and you have to understand some kind of registers. But we can just rely on the BGA hardware. So BGA is part of our graphics chip, and BGA hardware stands for the Video Graphics Array Hardware. It says yes, rather than tracking all of the register or the memory address to print the hello world in the screen, we can just specify, you can just track all the memory address in BGA hardware because BGA hardware is very defined, because BGA hardware is the hardware for the printing something in our screen. And to more elaborate about BGA hardware, there's a lot of important thing, but the core thing is that when we try to put our text on the screen using BGA hardware, we have to start from the 0xb8000 memory address, and that is starting point of the for the screen print. So yes, even as printing some kind of text to the screen, it requires you to understand some kind of memory address, because you are directly communicate with the hardware, and this specific memory address is for some kind of use of it. And important thing is 0xb8000 is the beginning point of it, and there's more. There's like color code of this, even printing a text of it. There's a foreground color bits, and there's like background color bits and those kind of stuff. But you can just search it. But I'm talking about the very core thing that we have to understand before we even make the bootloader. And I think this is it. And also last thing, very last thing. So when you're trying to write something on the screen, the BG hardware, right? This is actually a list of array, 2D array, two-dimensional array. So normally the columns are 80 and the rows are 25 in the BG stuff, and that is like related to the our like laptop screen or computer screen. And we store our like so this is gonna be 0x1000, right? I think yeah, this one. So that's gonna be starting point 0x1000, and that next gonna be your the text of it. For example, you want to put hello world, so H is gonna be here and E gonna be here, L probably gonna be here. Yes. This is very simplified, but actually we don't really store our H in here. We just change this H in Unicode bit, and we also change our color code like foreground color and background color into bit, and we combine into this text byte, and we store into this part of rectangular space, and of course text gonna be showing. And yeah, I think this is it. This is a key thing we have to understand to make our bootloader. Yeah, this is it. Bye bye.